Hey everyone, this is Team Tourist. What we have built is Reflexon, a self-healing infra agent. The problem that we solved is many engineers go to the dashboard and they try to read logs and the traces and the matrices manually. That is not a scalable solution. Why? Because it takes time and it can take hours. That could be done within the minutes. So that's why we built a solution using these signals. As far as we know, Signals is a observability platform, so we utilized it to fix this particular problem. So what is exactly we are going to show in the demo? What we have in the demo, we have our uh, broken database. So we are going to break our database intentionally and see how our agent is going to fetch the real telemetry from these signals and applies the fix. So let's see in real time. I'm going to send one ticket. Currently our database is broken, so let us simulate within a loop. I'm going to send one ticket after 1 second, and we are going to see on these signals how we are going to have alerts. So the first thing is we have set up the dashboards on these signals to see our db error rate within a specific period of time, and then we have cost per ticket over the time, like how many spikes are going to be jump up when the model is going to be expensive, and they are going to be jump down when the model is going to be less costly. So we have LLM input tokens, like how many tokens are going to be consumed by our LLM to diagnose and fix the issue. And similarly, the latency, like the request goes and the request come back, and the time taken during that duration is going to be visible through this dashboard particular chart. And then we have agent tool calc volume. This chart is going to be used by our LLM, and this thing is we are using Signos MCP, and the tools that are being used by our agent are going to be generate some matrices, and these matrices are going to be rendered on this particular agent tool called volume. And similarly, we have output tokens. So that's how we utilize the dashboard functionality of these signals, and then we set up the traces. We can see our each service traces. So far we have three services: control plane and the worker and the watcher service, and these are going to be here the duration and the http method and the duration in the milliseconds, and the request method as well. We can see and observe them what is actually going on in our whole services. And then we have matrices tab using these signals that is going to be showing us matrices. And then we move to the logs and we have alerts. The major functionality that we build using these signals is alert, like when error is going to be relevant to the database broken, it is going to be spike up. So currently it is going to be jumping up to the 0.53, and we have set up the threshold. And we are saying if our worker service is going to throw an error on the basis of database, then we are going to send an alert to this particular notification channel, and this watcher service is listening to all of those errors, and it will apply a fix according to particular error. So we have currently customer DB unreachable, and the error is not fixed yet. Why? Because Signos has a rolling window of around 5 minutes, and it takes around 3 to 5 minutes to send alert to our particular channel, and then channel is going to hit our webhook. Webhook is our actually endpoint that we configured in the watcher service, and the watcher service is going to consume the particular payload being sent by the signals and applies the fix. So finally our agent has switched back to the backup data, and it is serving the request now as usual. Now let us spike the cost of the agent. We are going to spike the cost of the model from the 0.02 to the approximately 0.85. Let us click on the spike cost and see how it is going to react. Yeah, so you can see 0.85 is going to be the cost, and now again Signals has to wait 5 minutes, around 5 minutes, to make the alert, and our alert is going to push into the notification channel, and then it is going to push to our webhook, and webhook is going to do an action according to the particular payload being received through these signals. So finally it has switched back to the chief model. As you can see, the GPT standard was earlier, and now it switched back to the GPT chief, and now our tickets are now being handled by our model. So that's how we actually use AI agents and observability platforms like Signos to handle the TB breakage and spike the cost. So that's all from the team Tourist. I hope you liked our demo. Thank you.